Okay, welcome to the workshop. This is the last in our series this semester, Intermediate R. But all of our workshops videos are available online. I'll show you the website at the end. It's montana.edu/data science. Workshop's going to be taught by me, Greta, and Sally, and we'll introduce ourselves. I'm Sara Mannheimer. I'm a librarian here.
I'm Greta, and I'm the facility manager for social data collection and analysis services. And I also have a research appointment. I'm Sally, and I'm a statistician for social data. Greta.
And so for today's workshop, we're going to be using an online tutorial, browser-based tutorial. The URL is here, and I also sent it via email earlier today for some of you and yesterday for the rest of you. So is anyone having trouble accessing this? You're all at this tutorial now? Okay, great. Oh, and for those of you online, there will be someone manning the chat at all times. So if you have questions, just type them into the chat and one of us will answer. So let's get started. Today's workshop, we will be talking about using relational operators, joining sequences of relational operators together with logical operators, creating conditional statements, if else, and for loops and functions. And if you haven't been in one of these workshops before where we use the tutorial, we built this with Shiny apps, which is like a suite of services that works with R. But basically R is running under the surface. And so you'll see these sandboxes here where we have everything, all the libraries loaded to do all the calculations here. But all you have to do is type into them, and then you can click run code or do command enter or control enter like you would do in RStudio to run the code. You can also highlight one line and run it that way. And then we're also going to have a series of challenges in here. And so you can submit your answer, but the right answer isn't always, there's sometimes many different ways to come to a right answer. So you can see the solution that we suggest here, but also know that if your code runs, it's probably the right answer. Let me go back to the orientation. You can, if you want to clear all of the data that you've entered in, you can use the start over button, which I'm going to do now, just in case there's anything cached in the browser. And then obviously next topic, you can click that and then navigate between sections on the left. I think that is all we need to get started. So I'm going to start with a little refresher. That should be fine. This is some of this we covered, I think, in Intro to R, but we'll do a little refresher here. So we want to know how to extract an element using the bracket notation. So a vector is one dimension. So what goes inside the brackets would be one number. And to extract elements, we can give their corresponding index number starting from 1. So for example, we are creating our own little vector here and saving it as X. So the vector is this series of numbers with a decimal point after them. And so to extract the first element, we use the number 1. So that's the index number of the vector. So let's try extracting that element. Oops, I'm going to do this. There we go. So when I extract that first one, you get 5.4, which is the first index in this vector, the first number in this vector. You can also use this, the colon, to extract between 1 and 3. So if we run this code, you'll see we get the first number, the second number, the third number by using that colon. Then you can also use the minus sign to exclude one of the indexes. So if you use this X and then in brackets -2, you're excluding the second number here, 6.2. And you can see that it's doing that. So let's try this challenge here. Run this code in challenge box 1. Why is R producing an error there, do you think, when you use bracket -1:3?
Everything should be bolded. Everything should be bolded.
Right. You can't go, but -1 isn't actually the number -1. It's saying don't include the index 1. So you can't then say don't include the index 1 all the way to index 3. It's like not right with our vernacular here or with our code. So you could say don't include, then use the concatenate function. Don't include any of those. Let's try that. There we go. So now it's only giving us the first and the fourth element. Or you could just say don't include, what did we say? Don't include 1 and don't include 3. Let's try that. There we go. Is that clear to everyone? Okay. Then we'll move on to extracting elements from a data frame. So a vector is 1 dimension, a data frame is 2 dimensions. So when you extract numbers from a data frame, you have to use a bit of a different notation. So we're going to create this little example data frame and save it as example_df. Oops, sorry, I have it highlighted. There we go. And then here is showing that you can also extract a single row from a data frame using this $sign notation. So right here, let's print out example _df. Print that out so you can see how the data frame looks. And then we've also run this code example_df, then use the $sign notation to just extract, oh, sorry, I said row, but column. So column A. So here it's showing just column A, 1, 5, 9, and 13. So then we'll do a couple more things with this data frame that we created. We can use the bracket notation, but use a comma between row and column. So here we have example df, and we're just extracting the first row and the first column. So let's run that. So the first row, the first column, we're getting 1, it's showing 1. Then this, if you use nothing in this first slot and then a comma and then a 1, you're extracting every single row that's in the first column. So let's do that. Sorry, every row, yeah. So we have 1, 5, 9, and 13, the entire first column. And then you can do it the opposite way with the entire first row. So there, we're extracting 1, 2, 3, and 4. Okay, so let's try here. What's wrong with the code below? If you want to extract the third and fourth columns from our data frame, which I'll print above so you can see, how can you do that? Take a minute to figure that out. So here I'll run this. It's only showing 3, 7, 11, 15. So that's the third row here. And that's because there's not this there's only 1 comma allowed in these brackets. So whatever comes after this comma, it's ignoring. So we could use this colon to say nothing from the first, sorry, nothing but the third and fourth columns. Let's try that. Okay, that's working. Or we could also use concatenate here and then do 3 and 4. Like that. So actually this leads to challenge 2. What if we wanted to extract the second and fourth columns? So you can use F bracket, no rows, and just the second and fourth columns. There we go. And then just as a reminder, there's the solution here. So if you get stuck, you can look at that. And let's submit our answer to you just for fun. Superb work. Sweet. Okay, next we'll talk about relational operators, sorry. So this tells how one object relates to another, and the output is a logical value such as true or false. So there are a variety of operators that you've used before in math, but they take a little bit of a different feel in data science. So we'll walk through some different examples. First, let's create a bunch of objects here. We've created W, X, Y, Z, an object called DNA1 that contains a bunch of DNA letters, and then another object, DNA2. So let's look at equality and inequality. So this tells whether an object is equivalent to another object and use a double equals, or it's not equivalent where you use an exclamation and an equals to say not equal to. So we'll try this. Is DNA1 equal to DNA2? No. And I see, yeah, there's a little bit of a difference, that's C and A. And then, okay, is it not equal to? Yes, makes sense. Then also greater than and less than. You can use the greater than or less than, but to say less than or equals to, you use less than equals to, or greater than or equals to greater than with an equals next to it. So let's try this. Is W greater than 10 and is X greater than Y? It's saying true and false. I can't remember what those are. Oops. And X. Is W greater than 10? Yes, because it's 10.2. Is X greater than Y? Oh, I'm gonna do Y too. X is 1.3, Y is 2.8, so the answer is false. Okay, then we'll do this inclusion. So this type of statement checks whether a character, a number, or a factor are included in a certain vector. And it's this operator, which is a percent sign, an in, and a percent sign. So that tells you whether a value is included in an object. So here, let's create a vector with colors. And then we'll ask, is there the color blue in the colors vector? Whoops. And it says no, because our colors vector has green, pink, and red. Then in the numbers vector, is 5 in the numbers, to which it says yes. Then we create the sum letters vector and we ask, are A and B together in sum letters? And it says true, true. So this, it's asking, you can ask, are multiple things included? So we could say, are A, B, and Q in sum letters? And the answer is true, true, false. And then this leads to challenge 3. Let's use our code to ask all of these questions. Which I'm just going to copy them from here. Run the code. So let's go through these answers and then Sally's going to talk more about the answers. So we have, is 2 times X plus 0.2 equal to Y? And it says false. Is hello greater than goodbye? It says true. Is true greater than false? It says true. And then what's the number of characters in DNA1? It says 15. So that's the only real straightforward one here. And then Sally will discuss the answers we're getting to the other equations here.
Okay. So yeah, some of these answers are confusing to why it comes up with true or false. So let's look at that more. So starting with the first one, the X time or 2 times X plus 0.2, is that equal to Y? And we kind of run these separately to inspect. We have the left-hand side and Y is the right-hand side, and if we just run this quickly. So it says this statement, 2 times X plus 0.2 is 2.8 and Y is 2.8, but we get false when we ask if they're equal. So looking at that, this is because we're using this double equals operator, and that sort of only works with Boolean types like true falses and integers, but these are decimal points. So we can look more into that. If we're using something like decimal points, we actually want to use this all equals function. So if we copy and paste, we've got all equals, and then we want to compare y and this 2 times x plus 0.2. So if we use this function, which in its description, it's testing near equality, a hint. Here it says true. So these things are equal, and we can look by their values that they should be equal. This is because the decimal points of how they're stored in computing or how R reads them. If you have decimal points, it uses like a base 2, and then it leads to rounding errors with certain decimal points. So basically it looks the same, but the way it's stored is actually a very small rounding error. So when you compare them, it's comparing those exact numbers that are stored not quite accurately. So it's saying they're not exactly the same as they're stored. So that's where if we have decimal points, we want to use this function. Instead, to be sure, yeah, so those are called floating point formats. That's like the storage thing. So this is just a technical thing with R and computers to be aware of. So yeah, decimal points be aware, but everything else you can use all the operators that we've talked about so far. So the next one on here is hello greater than or equal to goodbye. Greater than or equal to, maybe this should actually be this. And we look at that one. It says hello is greater or equal to goodbye, which kind of doesn't make sense. Like, how is it getting that answer? So another thing that's happening under the hood there, comparing characters, a hint to what's happening on that one, if you run this little section of code here, the system get locale, the output from this is saying c.utf8, and that looks familiar. It's a type of character encoding and how it's storing characters. So what's actually happening is it is saying H is stored as like Unicode or ASCII character 103, and it's comparing that to the first letter of goodbye, which G is stored as a character that comes after that. So this has a lower value than H has a lower value than G. So it's saying hello is greater than goodbye. Yeah, true. So it's not comparing what you think it is, or it's a confusing question to ask it to compare these two. So it's not, it's looking at each or the first characters in here. And if these were both, they were both H or both G and they were equal, then it would move on to the second character and compare those. So you have to be careful thinking about how things are encoded in R, like things like characters or decimals, and what question you're asking R. So you might get funny answers that you have to look into like this. And then the next one is true greater than false. That's true. This one's a little bit easier. Again, true and false are stored as 1 and 0. So if you were to change these to as numeric true, this output here. So you can see as if you look at this as a number, true is actually the value of 1 and false is 0. So 1 is greater than 0. So that's what that's giving us. And then the last question, DNA is longer than 5 bases. So we're starting off with how many characters are in DNA 1, and then is that longer than 5? That's this last output, and that's true, and that seems to make sense because that DNA 1 was this string here, and that looks like it's more than 5. So that one's correct, and we're using integers, and we're comparing the number of characters, not the characters themselves. So that one checks out. Any questions on those?
I want to just make the, like, display
Is it-
thing a bit bigger.
Oh,
for
is it
me in the
small?
back.
Yes.
Yeah, cool.
Sweet. Okay. All right. Okay, so let's do a challenge based on that. Challenge 4. What's going on with the code below? Why is R giving an error? And we have some letters, and we're saying some letters is not equal to A and C, true or false. So when we run that, it says, warning, in this whole statement, longer object length is not a multiple of the shorter object length. So any guesses what this is doing? Just put what we're comparing up here.
Just counting.
It's what?
Counting how many there are within the vector.
Yeah, yes, definitely. That is what's underneath the hood here is it's got 5 characters in the first thing we're comparing and 2 characters in the second thing we're comparing. And it's trying to compare those two things, but they're not the same length. So it is aware of like the length of each of these. And when you compare them, we're asking the question, are they not equal? So in these 2 lines here, we're saying, is A not equal to A? False. A is equal to A. So that's our first thing that gives us when we compare them. And then it goes on to the next element. So is B not equal to C? Yes, those are not equal. So we get a true. But then it's where our warning is coming from. It's saying these are not the same length. So what is it giving us for the rest of these true falses? It's saying, okay, is C not equal to, I don't have anything to compare to. So what it does is called recycling. So that's some of these diagrams down here. So yeah, these question marks is saying, I don't know what to compare to because they're different lengths. So what it does is it just keeps repeating this one to fill in all those blanks as many times as it needs to. So it's comparing A, B, C, D, E to A, C, A, C, A. And that's where we get, these are not equal, so that was false. These were not equal, so it's true. Now it's comparing C to A, recycling this A. That equals true, they're not the same. And same for the rest of these. So that's something you have to be careful of when you're comparing vectors, is it's going to compare each element, element-wise. And if you're not careful and you give it different lengths, it did give us a warning there, which is helpful, but it still gave us the true falses. So you have to be aware of what it's actually giving you output on. And then there's a note in here too, because we got lucky in this case, because it gave us the warning that they're not the same length, but more specifically that they're not a constant multiple of each other. So it's saying we needed 2.5 of these second vectors to equal the same length. So that's what the warning's about. And if this was 6 long and we had 3, we needed to repeat this 3 times, it would say, oh, well, it can recycle that an exact amount of times, so that's fine. So it wouldn't actually give you a warning, and it would just give you output. So that's where you might miss this. Yeah, just what I think this is what might happen, and what you might actually want to be asking this is not, are these not equal? You might want to ask, are A and C not in this vector? So that's maybe the question you're going for in the first place, and you try not equals. So we have it down here. Yes. So this is what you might actually want to be doing instead, is we can negate with the exclamation point. And so before we're asking RA and RB in some letters, the object some letters. But then we want to negate that, and instead of putting the negation in front of in, we put it in front of the entire statement. So we run this, and we get false, false. And so this is maybe what we were actually going for is A in some letters, and some letters was just A, B, C, D, E, I think. Yeah. So is it A not in some letters? No, it is in some letters. Is B in some letters? No, it is in there. So, yeah, something to think about when coming up with like what you're trying to get out of the comparison, like and how to code that. So not equals versus in or not in. Okay. All right. So let's see. So, so far, this has just been talking about how to compare like a left-hand side, a right-hand side. So inequalities, that type of comparison, and you get trues and falses. But we can also get, yeah. So we can also get the index. So just pull out whichever index number in that vector is true. So let's start with this. If we have some letters, the A, B, C, D, E again, we can give it a bunch of true and falses, one for each of the elements in this vector. And just like we were extracting elements before, we can tell it true or false, whether we want to extract or not extract that. So first element, we want to extract true, second true, and the rest are false. So we run that. It just gives us A and B because we told it we only wanted true to extract for the first two elements, A and B. And then if you don't give it enough of these, so you need a true and false for everything in this vector. And if you don't do that, it just gives you everything, I think. So you need something for everything in the vector, either true or false. Which if you have a lot of data, that could be tedious. So that's where instead of using true and falses for everything, if we just say we want to extract these certain elements, that's really helpful. And we can pick out which elements meet a criteria with the which function. So here's an example. We're going to create an object called x underscore 2. And okay. So this is x2. So it's integers 3, 5, 7, 9, 11, 13, 15. And if we use the which function, and now we put our relational operator in the which function, so we can maybe start it out asking, is x2 greater than 8? We get false, 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 true, 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 true. But if we put that in the which function, the output is here. It gives us the numbers 4, 5, 6, 7. And these are not pulling numbers out of x2. It's saying which elements in x2 were true in this inequality. So here's the values that are true and false. And here the 4, 5, 6, 7 were true. So it only returns the trues and it tells you their positions. We can also do that with the double equals here. This. So is x2 equal to 7? And you can perform that and it gives you false, false, true, true, false. Or if you put it in which, get what is the position of only the trues? And it looks like there's only one and it's in the third slot. So it simplifies things and it tells you some more information if you have a lot of data, especially. And this is with vectors, but you can also do it with larger, more complex data like matrices or data frames. So we're going to try doing that. Any questions about using which or the trues and falses? I think so far makes sense. Great, because we're going to be using that more, as you might have guessed. Okay, so here we're just creating a data frame, and this data frame we're going to call messages. It's going to have two variables, OkCupid and match. And these are the number of messages a person is getting on Monday, Tuesday, Wednesday, all the way through Sunday. So the number of messages on each day of the week for 1 week between OkCupid and Match, 2 different dating sites. So here we're just creating that data, and we can take a look. So this is, and our row names are the days of the week, and then our 2 variables, which we can see are, says they are double, which we noted to worry about, but it looks like they're all integers here, so we could convert them to integers. So now let's try using logical values with those. So use challenge 5. You can go ahead and try this. Use the messages matrix, so this up here. And we want to return logical values, so trues and falses, and answering the following question. So for what days were the number of messages at either site greater than 12? So try coming up with what might get you there. And I'll say it's simpler than you might think. Think about what inequality you might need. Okay. Any thoughts so far? Have you gotten it yet or still thinking? So it seems like there's a lot going on. We want true, falses, days, either site, greater than 12. But all we really need is messages, our data frame, and then greater than 12. And if we run this, it gives us this matrix back, which is exactly what we want. We've got trues and falses for each day of the week, and then for each variable, the dating sites. And it evaluates each number, and it goes through each one by one and says, is this greater than 12? So trues and falses for all of those. So that's pretty simple. It works on vectors. It works on matrices. It'll convert data frames to matrices. So that's what is happening here. Okay. So that was easy. Let's make it a little bit more challenging. So now use messages, and we want to return the rows to answer the following questions. So when were messages at only OkCupid equal to 13? And when were messages at only OkCupid greater than Match? So this one, are they greater than 13? And this one is one greater than the other for the 2 sites. So just gonna copy a solution. I'll just walk through it because we're gonna add a lot of parts together. Okay, so the first one. So we're starting with messages. So we'll start with that. And we want to pull out only the OkCupid column for this. So we're going to use our brackets and then comma column 1. So this is pulling out the OkCupid column, which we could do this several different ways, but I'm just going to say the first column. You could also use $sign OkCupid or the character string OkCupid instead of the 1. So here, oh, what did I do? Oh, I said message instead of messages. Make sure you name your objects correctly. Okay, so first we've got OkCupid extracted, and then we're gonna say greater than 13. Okay, so we have trues and falses. So that's closer. But we want to return which rows were greater than 13. So this is where we're going to use which.
Equal to 30.
Oh, yes, you're right. Sorry. Should work the same, please. Double check. Yep, good call. So equal to 13. So this is true or false whether okay, Cupid messages were equal to 13. And to get which rows those were, just put that all in the which function. And we get the only one was row 3. And so now we know which row it was, but maybe we want to figure out, like pull out that actual row. So now we can nest this even further to extract elements. This whole thing is just equal to the number 3. So we can use that inside brackets. And extract that from messages. And we run this, we want the rows and columns. So we've got the number 3 index in the rows position of this brackets. So this is pulling out the 3rd row so we can take a closer look. So you can get information from each piece of this. So the trues and falses, the which gives you which row it is, and then using this inside of brackets can pull out that actual row for you to take a look at. So this is the one that fulfilled that. So okay, Cupid is equal to 13. And maybe we don't want to look at match, so we could edit this and just say we only want column 1 of this. And that is just a value. So okay. So when were the messages at okay, Cupid greater than match? So we basically do the same thing. We're going to pull out, this is the okay, Cupid column. And are these greater than the match column? So this is sort of the core of what we're interested in. Okay, Cupid versus match, and it gives us trues and falses for each row. And then we can add the which function around it. And that tells us which rows this is true for. So rows 2, 3, and 6. And then we can pull out those rows by using bracket notation. So those values inside of rows and columns brackets, and we want to pull out the rows. So it's in this first position before the comma. And this subsets by those rows that are true. So yeah, you can get complicated quickly and get some interesting information from your data. And a shortcut might, instead, this is a small data frame and we can kind of spell all of this out, but it starts getting really long, especially if you're doing a lot of comparisons or something complicated. So you can use the subset function is a bit of a shortcut for this. Subset takes the first argument is an object, and then you give it your relational operator comparison statement. So if we, instead of asking, get the trues and falses with the comparison and then put it in which, and then put it in brackets to extract from the object, this will just do the extraction and skip all those steps or do all those steps. So this is x3, and we want to pull out anything where x3 is greater than 6. So it pulled out 7, 9, 11, 13, 15. So subset is useful for that. There's some advantages to using subset instead of, so there's kind of the 3 different ways. There's the comparison itself, there's which, there's the brackets, and there's subset. Subset accounts for, it'll let you know if there's any NAs, because if there's NAs in the data, that might mess up the comparison. But when you go back to this method, this is the simplest. So if you have a lot of data, it's sometimes faster computationally. So But you can really use any of them as long as you're aware of what's in your data. So let's see. So now let's try using subset to make things simpler. So using the data above, the messages, instead of using which, use the subset statement and extract the days that OkCupid is greater than messages at match. So that was this whole thing. This is what we started with to get that answer. And instead, we're just going to use subset. And we want to use subset on the messages data frame. And then we want to say is, so you can do this by saying, we were before looking at column 1, OkCupid, and then is that greater than column 2, match. And you can see these give us the same thing. This one's a little bit simpler, and you can even simplify this one more, make it more readable. Since you're telling it the object in this function, you can just name the variable if there's a column name. So you can just tell it, OkCupid, is that greater than match? And that does the same thing. And this is a lot easier to read in your code and understand. So, yes.
Oh, what, can you go back up to the code, please?
Sure.
Why do you need a comma at the end for the which function, but not for the subset function?
This one?
Yes.
So that's where subset is nice, because this starts to get confusing. There's a lot of brackets and parentheses and commas. So you're talking about this comma right here.
Yes.
So that is coming from, if we get rid of what's inside here, we're indicating what rows we want to pull out. And this just goes back to, we want to pull something out of the messages object, and messages has rows and columns. So by putting that whole which statement, we're saying pull out the rows and then comma, and then we don't put anything for the column position. So we're saying all columns. So like if we do 1, 1, this goes back to the notation of we want to pull out row 1, column 1, which is the value 16. So, but we replaced, instead of column 1, we wanted all columns, and then instead of row 1, we wanted all the rows that, oh, I copied all this, that fulfill this certain condition. So does that make sense?
Yeah, I guess I just don't understand why you don't need to do that for subset.
Because subset just takes care of it. It will take this object and it'll understand whether it's a data frame or a vector. I'll show you. So like, for example, this one was just a vector. And so here we're saying take everything in the vector and say if it's greater than 6. And here we're saying look at these columns and see if one is greater than the other. So it just knows what this object is. And here we have to do, in this whole thing with the brackets, we have to specify a lot of information about where and what we're pulling out. So that's where it is more complicated, and subset is a nice shortcut. Yeah,
Well,
does that help? Good question.
And subset always works on rows.
Mm.
There isn't an option to have it work on columns.
Mhm.
And so it's just its default operation is that it always gives you out all the columns if it's, data frame,
Oh, yeah.
because it's only operating on rows. Makes sense.
Yeah. Doesn't have a parameter to say columns. There's other ways to pull out columns, but yeah, yes, most of the time you're looking at certain rows, so that makes sense. Cool. So that's sort of that section. Any other questions about these different sort of ways to extract data and evaluate? So we're gonna add just a little bit on top of that. So far we've only asked it like one question, like, is it greater than, is it less than, equal to, things like that. But we can combine multiple relational statements. So we can combine them using and, or not. So starting with we use the ampersand symbol, and you can take two relational statements. Like here we have, is 3 less than 5 and is 9 greater than 7? So these would each have a true false, and we're going to combine them with the and. So it'll read this entire thing as one relational statement, and you'll get a true or a false for the entire thing, not for each of these things. So and is evaluating, it'll only give you a true if everything that you've included is true. So here 3 is less than 5 and 9 is less or greater than 7. So these are both true. So this would evaluate to true. But if we had 3 is greater than 5, that's false. 9 is greater than 7, that's true. So a false and a true, this whole thing would be equal to false. Because not both of them are true. At least one of them is not true. So it looks at the entire statement to see which ones are true and false, and tells you overall if they're all true or if more than one is not true. Or is kind of the opposite. So it'll tell you if at least one is true. So we use the vertical bar to indicate or. So yeah, is 3 greater than 5 true? Is 9 greater than 7 true? These are both true. So this would also evaluate to true because at least one of them is true. In this case, both of them are true. But
Does everybody know where the vertical bar is at on the keyboard?
yes, should be by either backspace.
Sometimes it's not
Or
a
is it-
solid line on the keyboard.
Oh yeah, it looks like this one is sort of like a colon.
Yeah.
Sorry, and I just noticed I got this first one wrong. So this would evaluate to true, but only one of these is true. 3 is not greater than 5. So this is false and true, but at least one of them is true, so the whole thing is true. And then the second one, 3 is not greater than 5. 9 is not less than 7. These are both false. So the whole statement is false because everything's false. There's not even one part in here that's true. So that's when this would equal false using or. And then not is actually exclamation point, and it just negates whatever function or operator you're using. So here an example is we're asking, is the number 5 numeric? This would be true. And if we put an exclamation point in front of the function to negate it, this would say, is 5 not numeric? And then you would get the answer false because it is numeric. So you can string together a lot of things, more than 2, to kind of narrow down results that you're looking for or fulfill conditions. You might also see these double symbols. So double and double or. These do not work the same as just the single ones. You don't usually use them. I've never honestly used them. And
I've seen other people's code where they use them.
oh,
So you have to be careful because
yeah.
then you have that to me, that makes their entire code suspicious.
Yeah, like if you're not aware that these are different and you use it, it might give you something, but yeah. Sometimes people use it not being aware that this doesn't mean the same thing as and or. And what these do is it only evaluates the first element. Because usually it goes through, like before in the matrix, you could see it was comparing like, A to A, B to B, comparing each of the elements element-wise. And this just takes the first one and then it stops there. So it gives you a single true or false for the entire vector matrix. So in a lot of these cases, you should actually be getting multiple trues and falses. So it gives you an output, but you have to pay attention to what the output is because you might not want to use these. And then these are just examples highlighting what you get with each of them. This is a warning from using the double thing, so we'll do this first. Okay. So this first line is looking at how the ands evaluate. So if we have two different vectors, it's comparing element y. So first it does true and true. Both of those are true. Both of those are true, so the output is true. Then it compares true and false. Not both of them are true, at least one is not true, so we get false. And then false and false. Both are false, so we get false. And then this is for the ors, so at least one has to be true. So true or true. At least one is true, get true. True or false. At least one is true, still get true. And then false or false. Both are false. There's not at least one true, so we get false. So I know it can be a lot to look at. So just, you know, take one element at a time and think about that statement. And you can double check all of those. Oh, and then this last one is using a double and what we got before is it gives us a warning. Length equals 3. In coercion 2, logical equals 1. So it's saying that the vector, you're comparing two vectors of length 3, but you're saying we just want a single true or false, one logical. Doesn't give us the output here, which I couldn't figure out, but this
So it just
should be true.
doesn't even work anymore.
Oh, okay.
It's not supposed to work. You might still see it if if you ask ChatGPT to give you some code, or you get somebody else's package that they wrote, 5 years ago. It might be in there, but it doesn't work anymore.
Okay, so that's good. It doesn't give you output because before this was just a warning and it would still give you the output of true because true and true is true. But now it's saying that's probably not what you want. Okay. So we'll just try a challenge using the ands and ors. So using the OkCupid vector, so that's from the messages object, we want to answer the following questions. Is the last day of the week, so the last day of the week is going to be the very last row. Is it under 5 messages or above 10 messages? And so we can figure that out, and to simplify it a little bit, we're just going to create this last object, which takes the OkCupid column and it takes the tail, the last one entry from that. So that's the last day of the week for OkCupid. So now if we do that, we just have this. So we can start with that. So this just pulls out 14. That's the last day of the week for OkCupid. And then we want to ask, is it under 5 messages? So this last less than 5. And we also want to know, is it above 10 messages? So is last greater than 10. And we want to know that in combination, and we want to know or. So use vertical bar. So we get a true. So that last entry, it was either or we know it probably can't be both, but at least one of these is true. It's either less than 5 or greater than 10. We saw looking at the value. Oh. That it was 14, so this part is true. Okay, and then one more is the last day of the week. So last between 15 and 20 messages, inclusive of 15, no, exclusive of 15, including 20. So what that would look like, let's see, last, is it between 15? So it's got to be greater than 15, and also not greater than, so less than 20 messages. And then this last part is saying we want to exclude 15. So this would be false if it's 15, but including 20. So what we actually want is less than or equal to 20. Oops. Perfect. You do have to retype what you're comparing on each side of the and, or I get an error like I did. Okay, so this is giving us a false. So it's not between 15 and 20, including it is not equal to 20. So it's 14. And then going back to using subset, we can do the same thing, use ands or ors within subset. So this is just a quick example of that. Looking at messages, is OkCupid less than 6 or is match greater than 6? So we can include two different statements in there, and it returns rows that OkCupid or match are less than 6. So one or the other. In order to be pulled out here. And then this one, that was bad days, good days. We want to see where both OkCupid and match were greater than 10 messages. So that we use and. So both of these have to be true for it to appear in the subset. And it gives us this. So all of these are greater than 10. So, okay. So I think next we're going to do loops, bigger data. So, and Greta's going to do that. Does it take a break at this point, or?
Yeah, let's go ahead and take a 5-minute break if you have to get some water or run bathroom as we switch. Then when we come back, we're going to put all these pieces together to do more complicated data analysis. Let's say 4:05. Start back again.
Again, I've unmuted myself. I have also enlarged this a little bit because we're going to be doing a lot of work that's going to use curly braces, and it might be a little bit hard to see. So I'll make sure to point that out. So we're going to use all of the relational operators and the logicals to make more complicated statements. We're going to start with if statements, and then we'll be working more into loops. So first we'll start with conditional statements. So in general, an if statement is if a particular condition is true, then we'll do something. So the structure is if, and then regular parentheses, and inside the parentheses is the condition. And then we have some curly braces that tell it what to do if that's true. So let's try this out. And there's some notes in here that because of other languages have different behaviors, but in R, an if statement has to be only a single value. Now we can have very complicated, multiple conditions that either evaluate to a single true or a single false, but we can only have one statement inside the parentheses. So let's give y a value of -3 for right now. And we're going to say if y is less than 0, print out the statement y is a negative number. And let's run that. Okay, so y was -3. So we got the statement y is a negative number. What happens if we change this to a different number, say +5? We don't get anything because we didn't tell it what to do if it doesn't evaluate to true. Okay, so you can just give it a statement where you only want it to do something if something is true. If it is 0, that should be the same behavior because it should still evaluate to false. So challenge 9, we're jumping right into a challenge. Using the last number from challenge 8, write an if statement that prints you're popular if the number of messages from OkCupid exceeds 10. So we're gonna have an if statement, and then we're gonna have some sort of condition, and then we're going to have curly braces, and we're gonna have some sort of statement. So the statement here we want to be you're popular. And so now we just need to enter in the condition, and so I'm going to pop back. We can go to our logicals, and we want OkCupid is greater than 10. Let's do something like this. Last, greater than 10. And let's see what happens here. And the last value was greater than 10, so we get the message you're popular. Sometimes we just care about if something is true, but most of the time we want to give it something to a behavior that we want to happen if it's not true. And so that would be an if-else statement. And we have else on a separate line, but generally I put my else on this closing curly brace line. And so we're going to have the same behavior if some condition. We'll do that if that's true. Else, if it's not true, we'll do something else. And so here we're going to say if y is less than 0, we'll say y is a negative number. Otherwise, if that evaluates to false, then we'll say y is either positive or 0. So let's try this. So we're starting out with y is -3, so we get y is a negative number because first statement evaluates to true. I run that. Oops. And we get that evaluates true, so we get y is a negative number. If we change this to 5, Now that evaluates to false. And so if we run this whole chunk, we'll get the statement y is either positive or 0. If we say that y is 0, it still evaluates to false, so we still get y is either positive or 0. Just like we have this way of accessing or testing these conditions, there is a built-in function called if-else, and just like with subset. So the if-else function has 3 parameters or 3 arguments. The first argument is the condition that you're evaluating. This next argument is what happens or what you want it to do if it's true. And the last argument is what you want it to do if it's false. So we can change that this multi-line statement or code into a single line. If else y is less than 0, we'll print out y is a negative number. Otherwise, we'll say y is either positive or 0. And again, we can try it with the same numbers. So -3, we get y is a negative number. +5, we get y is either positive or 0. So now we're going to take the if statement from challenge 9 and add an else statement. So you can either do the multi-line approach, or you can do the if-else statement. I'm going to start with the multi-line approach. And so if last is greater than 10, we'll say you're popular. Else, we'll say send more messages. And last doesn't change. So that should still be you're popular. Let's say we change this to first. Instead of tail, that would be head. And I'm going to do this without looking at what the first value is. And then we'll check it afterwards. So we still get you're popular. And we can check the first value was 16. So instead of playing around with that, let's change last to be greater than 15. We change that. Now that's going to evaluate to false, so we get the send more messages. And again, we can condense this down into if else last greater than 10. Spacing doesn't matter, it just makes it more readable. You're popular if that's true. Send more messages if it's false. And let me comment this out. Whoops, that is not the same. Delete this. All right. And we get the same thing. You're popular. If we change that to last is greater than 15, we get send more messages. Sometimes we'll have multiple conditions. So if one condition is true, do this. Otherwise, if something else is true, do that. Otherwise, if all else fails, do a third thing. So we can keep adding additional if-else statements together. We're going to call this if or else if statements. And they just keep adding on. So it goes in order. So the first one evaluates the first condition. As soon as it meets one of these, it stops. So it's not going to go all the way through. As soon as it gets one true, then it's going to bail out. So this allows us to do to test to see if it is 0. So if first we're going to say if it's negative or less than 0, we'll say y is a negative number. Else, if y equals 0, then we'll say y is 0. Otherwise, it must be positive, assuming we just have integers here. And so if y is negative 3, we get y is a negative number. If we put in 0, the second condition should evaluate to true. And we do get y is 0. And if we put in positive 5, it should go all the way to the third condition and we get y is positive. I like to have this next part in here. If you're going to use it, you're going to use it. If you're not going to use it, you probably won't. But if you ever have to figure out if things are even or odd, modulo is great for that. Or if you're trying to divvy up treatments into different plots of land or something, you might want to use a modulo. So that means it's just the evenly dividing things up and finding out how much remains. So if y is 6, 2 percent symbols together is modulo. So sorry, 5 modulo 3 or 5% 3 would be 2, because if you take 3 into 5, it's 2 with a remainder of 1. So we can use that for testing. So if x is 6, we should be able to ask it x modulo 2. And 2 goes into 6, so the remainder is 0. And then is it equal to 0? That's true. So we can, our statement could be x is divisible by 2 if that's true. If it's not divisible by 2, we could see is it divisible by 3? And then if it's not divisible by 2 or 3, then that's what we'll say. And if x is 6, x is divisible by 2. Let's try 7. Which message should we get out?
Not divisible by 2 or 3.
Not divisible by 2 or 3, and that's what we get. And then let's try 8. And we get x is divisible by 2. It hits the first one. So let's try 9. Should get to the middle one. And it is divisible by 3, but not by 2. So again, most people probably wouldn't use that, but because it's such a strange combination of characters, I like to showcase that. So those are conditional statements. And now we'll go into looping. So looping is like a conditional statement, but we're going to do it multiple times. So in a loop, we're going to go to a condition, see if it evaluates to true. If it's true, we'll do whatever we want, whatever conditional code we want it to run. And we'll keep doing that until the condition evaluates to false. A lot of times it's, let's do this 50 times. And then as soon as you get to the 51st time, it's going to stop. It could also be while x is less than 50, you're going to keep doing it until x is greater than 50, and then we'll stop. And this is a great way to iterate, replicate the same set of instructions many times. So if you're doing a lot of copying and pasting, we want to use a loop, a for loop or a while loop as much as possible, just to prevent any copy paste errors. In surveys, we do, I do a lot of data summaries. There's a very set, fixed set of instructions that I want to do based on the type of survey question it is. So I use I use a for loop. So I go through all the variables and then I just run the code, run the appropriate code based on the type of variable. I only have one set of instructions, and so I don't have to worry about copying and pasting things incorrectly. All right, so let's start to talk about for loops. first. They're the more common one because they have a clearly defined start and stop. And like I said, we might do this for a sequence of numbers, a certain set number of times. So for I in some sort of sequence, such as a range of values from 1 to 100, doesn't have to start at 1, it could start at 3. You could go backwards, you could start at 100 and you could go back to 1. And each time through for each index, you'll evaluate the code. So for instance, if we have some sort of, if we have a variable that has their stop point in it, then we can change that in one place. It makes it a little bit cleaner, especially if we're going to reuse that a lot. Again, code reuse helps prevent copy paste errors, but we could also put the 100 in here where num is at. So this is like if else, only it's for, and then in parentheses, we have the condition. The other thing to note is that in for statements or for conditions, we don't have percent symbols around the in. This is because this in is much older code-wise than the percent in operator. And so at that point, it didn't need it. And now in has been used in multiple ways, but it's just straight in. The word in, and then curly braces again are being used, and then a statement or multiple statements that you want it to evaluate. So we could also, instead of just saying 1 to num with the colon in between, we could have another variable that was the sequence of all the numbers that we want to evaluate, 1 to 100 sequence there. And it doesn't have to be consecutive either. We could just do all evens, or we could do skip things. And we're going to show some examples of that. So let's start simple. For index, that's traditionally what we can do. It can be multiple letters. You can use IJK. Just typically it's something short so that you can reuse it a lot, but it doesn't have to be. And so for I in the numbers 1 through 10, we're just going to print out the index. So let's see what happens here. And we get the numbers 1 through 10. And then this last year on line 5, we have I. That should be, if all of our code evaluated properly, this is a good check. It should be the last number in our sequence. If you get an error message, you can always ask it, what is I? And then it'll tell you at what point things broke. All right, so let's add we're going to pretend like we don't have vector-wise addition, and we're going to go item by item through 2 vectors and add it together in a for loop. Now we do have vector addition, but again, this is a good example. So we're going to have the function seq is a sequence. We're going to go from 1 to 10 by 1 for x. And so that looks like the numbers 1 through 10. For y, we're going to go from 10 to 28 by 2s. So all the even numbers from 10 to 28. And let's just make sure that they're the same length. They should line up. And they do, and we're going to next create an empty vector to store our added quantities. So z, we're going to repeat NA, or not a number or missing value indicator, for the length of x. So we should get as many NAs as x is long. So let's look at z. And so we do get 10 NAs. And that could be zeros or negative ones or whatever placeholder you want to put in there. And so now for I in 1 through 10, we're going to go through and we want to add item by item. So we want to take 1 and add it to 10 and put it in the first spot in Z. And 2 and add it to 12 and put it in the second spot in Z. So for instance, we want the first item of X, and we want to add that to the first item of Y. So I'm using square braces. And if we run that, should be 11. And we want to store that in the first item of Z. So I'm just going to put that here. Whenever you're building a loop, it's always good to just look at what one iteration would do to make sure that's working properly. And we got 11 and it put it in the first slot of Z. Okay, so now hopefully we have an idea of what we want inside of our loop, but instead of ones, what do we want? Eyes, yes. We want to change those every single time. And now if we run this, we get 1 plus 10 is 11, 2 plus 12 is 14, and we get exactly what we want. All right, any questions about that? So, like I said, we can do item by item addition without doing this in a loop. So we do need to copy X and Y. Autocomplete on Learn R is challenging. So we can actually just do X plus Y. And if we wanted to save that into Z, we could just store X plus Y to Z. But again, we were just using the for loop to illustrate the behavior. All right, so let's do a hot spicy challenge. Let's do a recursive for loop. So this is going to go to a data set that we used in the introduction to our workshop. It is involving fish captured in 3 sections of the Blackfoot River. And things were measured like the species of the different types of trout, their length, their width, I think that's all that was measured. Let's take a look at what's in this data set. So there's a really long link here. In the Learn R environment, this is already loaded, but if you wanted to copy and paste this code into our studio script, then you'd want the whole thing. So I'm going to just print out. And also, if you're in our studio, you do not want to print out the entire data frame. But when we are in this Learn R environment, it will actually make a nice paginated table. So we get, there were different boat trips out. They did a capture, recapture, so some of the fish were marked or not. Length, weight, the year, the section of the river, the species. And then we've got this year by species interaction variable. Then we got some other, we got a condition index in here as well. So lots of different information that we're not going to particularly need right now. Let me put in back in here. So what we want to do is we want to get a subset, but we want to do a systematic subset because we're going to use it for training a particular model, and then we're going to test it with the holdout samples. So we want 1,200 rows that we're going to use for our training data, and then the rest will be in the test. So we want to sample every 7th row from the data set, starting with the first row until you've sampled 1,200 rows. So the number that we want to test is, this is technically training, but we're just gonna 1,200 for training. And then we're going to create this vector, initializing it with missing values, the length of our training set. Oh, okay, all right. So we did want this to, this is assuming that we're gonna hold out. Okay, I remember now. We're gonna hold out 1,200. We're gonna use the majority of them for training. So we're going to hold out 1,200 from our, and it's complaining because we need to fix some things here. So we're initializing our SAMPs. Let's just check. Let's look at the first observation. Well, we know the first index that we want to hold out is the first observation. And then after that, we're going to do every 7. So we're going to right away store in the first row the value of 1. And it's not printing anything out because we need to ask it. And again, because it's 1,200, I'm just going to look at the head of SAMPs. And so we have a value of 1 and then a bunch of missing values. So now, how do we get from 1 to the next row that we want? So we want every 7th starting with 1. So we could do sequence, SEQ, from 1, actually, I go up here. Let's grab a sandbox. I'm going to clear it out. I'm just going to do 100. All right, so this is what we want. We want to do the same basic idea in a for loop, okay? Recursively. So we want 1, and then we want 1 plus 7, and then 1 plus 7 plus 7, and then 1 plus 7 plus 7 plus 7. So what's the pattern here? This is 1 plus 7 times 1. And this is 1 plus 7 times 2. 1 plus 7 times 3. But this is the first time through. Sorry, this is the second time for the second storage spot. This is for the third storage spot. This is for the fourth storage spot. So instead of 1 here, what is this if we're using our index? Or using the fact that this should go in the second storage spot. This should be the second row we pull out. 2 minus 1. That should be the second row. The third row should be 3 minus 1. And what's another name for 3? 4 minus 1. Okay. So now we're going to use that information or this pattern here. And we're going to start with I. We're going to go until end testing. Right, because that's the number of rows we want to pull out. We're going to start with 1 and then 7 times I minus 1. So we're going to go back. Now let's see. look. I'm just gonna put in length of these, not length, I want, because these are matrix, data frames, so I want n row of the testing and the training. And we should probably get the original number of rows. All right. So there were 9,000 original rows. In our testing set, it's 1,200. And in our training set is the rest of them. Let's look at the head of the testing set. Because it should be this first row, and then 1, 2, 3, 4, 5, 6, 7, 10, 8, 8, 5 should be next. And we did get the first one, and then 10, 8, 8, 5 was the second one. Okay. All right. So again, we could use the sequence to take every 7th observation instead of doing this recursive for loop. But it's always good to try these out. That's kind of complicated, complicated process, complicated thought process, a lot of discrete and combinatorics mathematics there. Any questions about that? Well, if we do one loop once, we can do another loop again. So we can nest our loops. And so you could use this to iterate over all rows and columns of a matrix if you wanted to do that, or if you had a more complicated process. So let's say that we have on the outer loop, we want to go from 1 to 5. And then in the inner loop, we're actually going to iterate over a character vector, J in the character vector A through E. And then we're going to print the combination of I with J together. Let's see what happens when we run this. So we get 5 ones and then A through E, 5 twos, A through E, and so on. So again, this could be a way that you could go navigate through an entire matrix if you needed to, or if you had an outer process and an inner process, then that's how you do that. Note, it's really important that you use different indicators for your indexes in the different loops. So again, this is where, I, J, K are typical indicators for different loops, but they could be named, they could be outer, mid, inner, but then that gets complicated. You could do 2 letters like I, and JJ if you have multiple different loops in your code. All right. So let's do, we're going to put all this together and we're going to define our own function. We're going to start with a simple function, and then we're going to hopefully have enough time for a more complicated function. And so we've been moving from levels of complexity. If you've got a process that you're going to repeat over and over in one particular section of your code, a for loop would be great for that. Or we didn't talk about while loops, but a while loop is a similar idea. But if you're going to do one thing here and then do a bunch of other stuff, and then you want to refer back to that thing that you did already, without copying and pasting, we could define our own function. We've used other functions in this workshop, and we've used functions in other workshops, such as mean, or we've created tables. If you're doing statistics, LM gives you a linear model. These are other functions that we haven't talked about particularly, but you might have encountered.
And you can always, most of the time, you can always look at the guts behind any of these functions. If you just type it into RStudio without any parentheses, it should print, unless it is locked down in a particular way, it should print out exactly what's going on in that function. But we can create our own function. And we want to make sure that we're careful and we pay attention to what the tab complete is telling us so that we don't reuse names whenever possible. Let's create a function to convert inches to centimeters. I can never remember how to do this, and so a function that does this might be nice, especially if I have multiple people that can collected data on fish and one person collected it in English units and another person collected it in metric, and we want to kind of bring everything together. We'll have one nice function that does that. So functions are really only useful if they're stored in something that can be called later. So we're going to call this feet underscore inch underscore 2 underscore cm. And we have the storage arrow. Function is what we're going to do. So that's like if, else, or for. And then in the parentheses, we're going to give it the parameters or the arguments that we're going to expect. And these are named. So the first one is we're going to expect to be the feet. The second one is inches. And then again, curly braces. We're going to temporarily store in inches the feet times 12 plus the inches value. And then we're going to take the inches and convert it to centimeters by multiplying by 2.54. And we're going to be explicit about what we're returning, and we're going to use the return function. We could just type in cm and it would return that. All right, so let's run this. It's not going to do anything because we need to actually give it some numbers. So now that we have this user-defined function, let's try converting your height to centimeters. And so let's say 5 feet. I'm 5'6", so 5, 6. I'm not going to put in the names of the arguments. I'm just going to use the fact that I know the order. So I'm 167.64 centimeters, but if I wanted to be explicit, I could say feet equals 5 and inches equals 6. And I get the same thing out, but if I name the arguments, I can move them around. And I don't have to keep them in the same order. And I get the same value out. All right. Any questions about that? Okay, now we're going to build a more complicated function, but we're going to build it piece by piece. One more thing before we get there. In this function, inches and centimeters only persist for a single computation. We can't then say, what is the value of inches? It will complain. Inches not found because inches only exist during the lifetime of that function. So another way of saying that, let's say that x is 10. Let's define this function without any arguments. Inside the function, we're going to reassign the value of 1 to x, 2 to y, and then concatenate them out. And then we're just going to call f, no arguments. And then we're also going to look at x again. And so f prints out 1 and 2 because inside this function, x was 1 and y was 2. But outside the function, x was 10. So that if we don't deliberately reassign the value of x, it's not going to overwrite it. That being said, you should probably avoid reusing names inside and outside of functions so that you don't confuse yourself. Okay. So let's just really quickly go through this one. So in this function g, we're assigning the value of 2 to y. And now we're not overwriting x. we're going to assign the value of 15 to X outside of G, and let's see what happens here. It's going to run the first part. And so now, because we didn't overwrite X, it will use the outside function or the global value of X inside that function. And it's always better policy, if you're going to use a global value, have it be an argument, instead of, so that you don't accidentally reuse something that you don't intend. If we call G, or if we reassign X to 20 and call G again, it does update X. Okay. All right, so let's do this really complicated normalization or scaling. So we're going to take an observation, subtract the minimum value of those observations, and divide it by the range of possible observations. And we should get values between 0 and 1 after we do that. So we're going to do this first. Let's just do it without a function. So this is really hard to read. And we're going to do this for both length and weight. We run this. We have to print them out. And I'm going to do head, so I don't get all 9,000 observations. So head of length scaled, head of weight scaled. All right, so we've got some missing values here. We are seeing values between 0 and 1, but let's just check. Let's do range to get the minimum and the maximum value. That should be, again, between 0 and 1. And we do need to tell it to na.rm equals true, so skip any missing values. All right, first one is fine. The second one is a value greater than 1. So we had a mistake somewhere in that complicated scaling, and you might see it right away. But this is another reason why we want to do a function, so that we can make sure that we can guarantee that we're going to do this calculation correctly, because this could be a vital calculation. We don't want to publish something incorrect. So again, we're going to go piece by piece. So we're going to work with the length. And we want, so we're just going to focus on a particular column. We want to rescale the length to be between 0 and 1. So we're going to take the length and we're going to subtract the minimum of all the lengths, removing any missing values. And then we're going to divide by the maximum . So we're going to get so the length minus the minimum length. So let's start with looking at just the length. And this is going to be a lot of values, but 232, and then we're going to subtract off the minimum. And then we want to look at the range. So we want to take the maximum value minus the minimum. That's a single value, so 970. So we want to take all of the lengths minus the minimum divided by 970. And we should get this values between 0 and 1. So how many inputs did we have? We had the length vector, we needed the minimum, and we needed the maximum. So 3 inputs potentially. But we could actually calculate the minimum and the maximum from the length vector, right? So we really only need 1. So let's call that X. And so we're just going to first replace anytime we see the length vector with X. So there's one instance. There's another one. 3 and 4. and that should run. Okay, we should get the same thing out. So right away, this would have fixed our copy and paste error, right? Because we're making sure that we're consistent in the vector that we're using for scaling, rescaling. Let's save this in X rescaled. And our range is from 0 and 1. Okay, so the range gives us the minimum and the maximum. So if we wanted to access the minimum, we could use our square bracket notation. So if we get the range of a sequence of numbers from 1 to 5, the minimum is 1, the maximum is 5. So min we could do square bracket 1 and then copy that in square bracket 2. That gives us, the first one gives us the minimum and the second one gives us the maximum. And that's a single function that we're using 2 different parts of. Okay, so now we're going to create another intermediate variable called x range. That is the range of x. And we want to make sure that we remove any missing values. Length doesn't have any, but we know width does. And print that out. So the minimum was 16, the maximum was 986. Now let's go back up to 14 and rewrite this. So the minimum, we want x range, square bracket, what? Get the minimum.
1.
1. Yep. And for maximum, x range 2. And minimum was x range 1. And we get 0 and 1 again. All right, so we're almost ready for a function. We're going to take this, except for the input vector, x, and put that into our body. Oops. Body of the function. Learn our weird indents. Let's call this rescale. And how many arguments do we need to give it? Just the vector, right? Just x. It's going to take x, calculate the range, store it in x range. We don't want to print that out all 9,000 times. So we're going to get rid of that. Then we're going to take the x range and the x vector and calculate the rescaled vector. And we want to return, we're going to be explicit about what we're returning. We're returning x rescaled. So now we've written this function, let's test it on a simple vector. Let's call it simple. And so we're going to call rescale simple. And so we're taking a value of 1, subtracting the minimum, which is 1, so we should get 0. And 5, we subtract the minimum of 1 and divide by 5 minus 1, so we should get 1. And using that, we can test this out. We scale Blackfoot fish length. And let's look at the head of that. We get values between 0 and 1. And we can do the same thing for weight, which was our problem before. So let's change head to range. Both of them now should be between 0 and 1. And so our rescale function, so even though our function handled missing values, when we called range again on the rescale value, we still need to put in that we want to remove the missings, and now it's between 0 and 1. So we already did challenge 18. So down here is the process of creating a function, which I walk through. You can end it with creating a data subset with just the species, length, and weight variables from all the data fish. And then you could do this other function to get the Fulton's condition factor if you want, but we're going to go ahead and skip that. You can work on that on your own later. The reminder that we do have the solution in here, and these tutorials will exist for as long as they exist. Occasionally they go down when the math department is updating the server. If they do go down and you're trying to something out, don't hesitate to let us know, because sometimes we don't know when they've made changes or broke something, and we can let them know. Any questions? So this was very like technical process, getting into some of the nuts and bolts of the computer science coding that makes our work and how to be able to, but hopefully the goal is that either you can use some of these techniques to help with reproducible research, or you can look at code that somebody else, including AI, has written and be able to decipher it. Because in my experience, AI really likes for loops and functions, even when it doesn't necessarily need to create its own functions, it does. So hopefully you can actually read those or read somebody else's code too. Sure.
Oh, I guess I don't have to, well, I just wanted to do a little wrap up, just show you our other resources. So we have at montana.edu/data science/ so you can sign up for future workshops, which we don't have any more this semester. It's up in the air whether we'll do them in the future, but then we also have recordings of all of our past workshops here, including materials. And we'll have data science training available in some format, just maybe not like exactly like this. So hope that you found this helpful and that you can use these in the future. Okay, thanks.
Thank you.
Thank you.